Good day, everyone. I am here to solve these problems as part of our midterm exam in Math 13 Section K. 1. Proving. Prove that CSC squared A minus cot squared A is equal to 1. So, first step, you need to define. By definition, CSC squared A is equal to 1 over sine squared A, and cot squared A is equal to cos squared A over sine squared A. After that, we replace. We all know that 1 minus cos squared A is equal to sine squared A. So, we replace again. Replacing 1 minus cos squared A to sine squared A, and sine squared A minus sine squared A is equal to 1. So we prove that CSC squared A minus cot squared A is equal to 1. CSC to the power of 4A minus cot to the power of 4A is equal to 2 cot squared A plus 1. First, we factor out CSC to the power of 4A minus cot to the power of 4A, because this is a complicated statement, these two. So we solve first this one. We factored out CSC to the power of 4A minus cot to the power of 4A. We all know that CSC squared A minus cot squared A is equal to 1. And we solve for CSC squared A plus cot squared A. CSC squared A plus cot squared A. We replace CSC squared A to 1 over sine squared A, because we all know that CSC squared A is equal to 1 over sine squared A. And cot squared A, we know that cot squared A is equal to cos squared A all over sine squared A. And we add 1 over sine squared A plus cos squared A over sine squared A, so it's equal to 1 plus cos squared A over sine squared A. Now, we solve for the second equation, which is 2 cot squared A plus 1. 2 cot squared A plus 1. We factor out 2 cot squared A to cot squared A plus cot squared A. So, namagang pagpilpil. Cot squared A plus cot squared A plus 1. And we know that cot squared A plus 1 is equal to cot squared A plus 1 is equal to we all know that cot squared A plus 1 is equal to CSC squared A. And by definition, cot squared A, it's 0. Cot squared A is equal to 1 over sine squared A. So 1 over sine squared A, and CSC squared A is equal to cos squared A all over sine squared A. So we replace. Then we add 1 plus cos squared A, 1 over sin squared A plus cos squared A over sin squared A. So 1 plus cos squared A all over sin squared A. So it's equal. We proved that CSC to the power of 4A minus cot to the power of 4A is equal to 2 cot squared A plus 1. Number 3. Show that CB is equal to tan A and AB is equal to sec A, and write these values in their corresponding lines. Obtain 5 identities from figure thus prepared. 4 by setting each of the functions sin A, cos A, cot A, CSC A equal to its value read from the figure, and 1 by application of the Pythagorean theorem to the figure. So let's get started. We all know that tan A is equal to opposite side over hypotenuse. So opposite side over hypotenuse. But the opposite side is equal to side BC or side CB. So side CB all over 1, it's equal to CB. So tan A is equal to CB. Second, we proved that AB is equal to sec A. So we all know that sec A is equal to hypotenuse over adjacent side, hype over adjacent, and the hypotenuse is side AB over 1 or AB. So sec A is equal to side AB. CB is equal to tan A. We replace side CB to tan A. So we put tan A here. And sec A is equal to AB over 1 or AB. So we put sec A here. So by setting each of the functions, first we solve for sin A. Sin A is equal to opposite side over hypotenuse, and the opposite side of sin A is tan A, tangent A over secant A. So we put tan A here over sec A, and then we solve for cos A. Cos A is equal to adjacent side over hypotenuse. The adjacent side of cos A is 1, and the hypotenuse is sec A. And then we solve for cotangent A. Cot A is equal to adjacent side all over opposite side. So the adjacent side is 1 and the opposite side is tan A. Last, we solve for CSCA. CSCA is equal to hypotenuse over opposite. Possible. CSCA is equal to hypotenuse over opposite side. So the hypotenuse is secant A. Right, sec A here. Akong pen kay namatay na. All over opposite. So the opposite is tan A. And then 1 by application of the Pythagorean theorem. So we know that Pythagorean theorem is AB squared is equal to AC squared plus BC squared. And then AB squared, replacing AB squared is equal to sec A squared equals AC is equal to 1. So 1 squared. And then BC is equal to tan A. So plus tan A squared. And then simplifying, so sec squared A. Yawa. So 1 squared is equal to 1 plus tan squared A. So this is the Pythagorean theorem. The application of Pythagorean theorem. Thank you everyone. My name is Jason Mayagma, civil engineering student of Siliman University.